Well, here we are again. Something that made me really mad today was I was just out on my bicycle, enjoying the sunshine, when it started snowing. Can you believe that? I can absolutely see that I was cycling along in the little shorts and my legs got almost completely frozen solid. Absolutely terrible. Well, anyway, they've asked me today to look at the sequences and the nuth term. What on earth does that mean? Well, I'll tell you. Well, I'll try to tell you. It's called the nth term, not the nuth term. Alright, so we've got three sets of numbers all in a line here. And what we are interested in, or what I am very, very, very interested in, is whether we can extend these numbers a bit further on. So we're looking at going like that for each of them and seeing if the pattern continues, right? So that is what today is all about. We all love patterns, and 2, 4, 6, 8, 10 is a very nice pattern. And I'll show you how we're going to do it. And we're going to start like this. Okay, so the most important thing you've got to do is to write a number above each of these. And the number you're going to write is the position of each of these numbers in this sequence. So we're going to start off, I'm going to draw a line over here so that you see they're separate. I'm going to start off with this one. Let's say we want to find out number 6 and number 150. Number 6 would not be so hard, but number 150, that would make things very, very difficult. So let's see if we can find a plan here. We know that number 6 is going to be 12, but what do we know about the relationship between these numbers? And this is why I'm going to write n. Okay, and this is why they say nth term. Stupid thing to say, but we're going to do it anyway. Look, where n equals 1, the number in our sequence equals 2. When n equals 2, the number equals 4. When n equals 3, the number equals 6. Do you see what we're doing? So 1 and 2, 2 and 4, 3 and 6. So we can see a relationship here because this number is just double this number. This number is double this number. So would you agree with me that our sequence, let's do this. Let's call this 2. And then we can say that t equals 2 times n. Because wherever we have n, then we can predict what our t is going to be. So where n is 6, we know that t is going to be 12. And something that you probably didn't know, when n is 150, so the 150th turn in the sequence, t, 10, is going to be 300, because it's still just 2 times n, 2n. Right, let's have a look. We're going to carry this on, the same sort of logic, and here is our t, here's another t. We're going to look at this one here, first of all. Now, let's have a look. These numbers here are going up in threes, so 4 to 7 is 3, is 3, is 3. And that means that we know already that t is equal to 3n and something. So the 3 comes from the gap, where the gap is 3 each time. That will be the number we put in front of n. But there's a problem, because in this case 3n, so that's 3, is 3 times 1 is 3. Our number is 4.
3 times 2 is 6, but our number is 7. 3 times 3 is 9, but can you see a pattern? There's a pattern emerging, and what we've got to do is add 1 on each time, and then it will work. So our little equation here is t equals 3n plus 1, because 3 times 4 is 12, plus 1 is 13. 3 times 5 is 15, plus 1 is 16. So 3 times 6 is 18, plus 1 is going to be 19. And then the tricky one, 3 times 150 is 450, plus 1 is 451. And that will be the answer for the 150th time. Let's do it one more time. And I must stress, I'm going to write it down, the gap. So if you have a regular gap, that equals what we would call the multiplier. Okay. So in this case it was 2, in this case it's 3. Let's see what it is in this case. The gap here is 8 times 4. 12 16 is 4. We can already see 16 times 4. Yeah. So this is going to be 4n. Let's see, 4 times 1, this is 8. 4 times 1 is 4. So there's a problem here. 4 times 2 is 8. 4 times 3 is 12. But can you see how we solve this? 4 times 1 is 4, plus 4 is 8. 4 times 2 is 8, plus 4 is 12. 4 times 5 is 20. We got it. The equation here will be 4n plus 4. So, for the 6th time in the sequence, we're going to go 4n. 4 6s are 24, plus 4 is 28. Yes, that seems to continue the sequence very nicely. And then finally, 4 times 150 is 600, plus 4 is 650. Okay? So, this is really important. Get this right and you can't go wrong. And these people who make life so horrible for small mathematicians, they can take a running jump because we sorted it.